Session, I'll be going to explain very interesting example of root locus where we have transfer function of system which is what given by k into s plus 1 divided by s into s minus 1 into s square plus 4s plus 16. So let us begin this example with step by step, and then at the end we'll be plotting root locus for this example. So step 1 for root locus, that is to identify Loci. Now we will be identifying Loci based on number of poles and number of zeros. So number of poles in this is 4 and number of zeros over here, that is 1, s is equals to minus 1. So Loci, that will be maximum of poles minus 0, and that is 4. So 4 Loci are there, and position of poles, so that will be at s is equals to 0, s is equals to 1, s is equals to minus 2 plus j and square root of 12, and another pole that is at minus 2 minus j square root of 12, and this is minus 2 plus j square root of 12 is 3.46. So these poles are at minus 2 plus j 3.46 and minus 2 minus j 3.46. Now next step, that is based on asymptotes. So step number 2, that is total asymptotes. So total number of asymptotes that we can calculate as per poles minus 0. So here 4 poles are there and 1 0 is there. So total number of asymptote, that is 3. Now next step, that is to identify centroid of asymptotes. So centroid of asymptotes, that we can calculate by basic formula. Sigma c is summation of real part of pole minus summation of real part of 0 divided by pole minus 0. So here real parts of poles, that is 1 minus 2 and real part of 0, that is at minus 1. Here I forgot position of zeros, that is at minus 1. So real part of 0, that is at minus 1 divided by 3. So this will be minus 2 by 3, which is minus 0.67. And fourth step, that is angle of asymptotes. So for angles of asymptotes, we need to have a basic formula. Theta is equals to 2x plus 1 divided by poles minus 0 into 180, where 3 poles are there. So x value will be 0, 1 and 2. If I place 0 in this, so that will result into 60 degree. If I place 1 in this, in that case it will be 180 degree. And if I place x is equals to 2, angle will be 300 degree. So that is how we can identify how asymptotes are there in this given root locus. Now next step for this example is to have a calculation of breakaway point. So for breakaway point, it is again bisected into few steps. So next step, that is to have a calculation of breakaway point. Now breakaway point, that is again bisected into few steps. First is characteristic equation that we can identify by 1 plus GS HS is equals to 0. So that is 1 plus GS HS, that is given by K into S plus 1 divided by S minus 1 into S square plus 4S plus 16, and that is equals to 0. So this is how it is given. Now let us simplify this. So this will be S into S minus 1 into S square plus 4S plus 16 plus K into S plus 1 is equals to 0. So this has to be S raised to 4 plus 3S cube plus 12S square minus 16S plus K into S plus 1 is equals to 0. Now based on that, we will be calculating dk by ds, that is equals to 0. So here k is equals to minus of s to the power 4 plus 3s cube plus 12s square minus 16s divided by s plus 1. So here dk by ds is equals to 0. So we will be having this differentiation where denominator plus numerator's differentiation. So this will be 4s cube plus 9s square plus 24s minus 16 minus numerator as it is s raised to 4 plus 3s cube plus 12s square minus 16s, and denominator's differentiation is 1 divided by s plus 1 whole square, and this is equals to 0. So that will be resulting into this equation, and I'll be directly writing simplified version of it. The reason is my focus is more towards how we need to plot this. So you can calculate this and you'll be having proper answer based on same, but I'm writing this equation directly right now by, it will be 3, this will multiply with 0, so it will be 0. So this will be 3s to the power 4 plus 10s cube plus 21s square plus 24s minus 16 is equals to 0. Now there are so many methods to have a solution of it, but in exam I think you should use it by calci with trial and error method. So here values of s are, s is equals to at 0.46, at minus 2.22, and some other values are there, but that is not useful. The reason is it is having imaginary part. So let us consider these two values only. Now last step for this is to have a calculation of intersection to imaginary axis. So step 7, that is to have a calculation of intersection to imaginary axis. So intersection to imaginary axis. Now intersection to imaginary axis, that we can calculate by few steps, where first step is characteristic equation, and that we have recently calculated. This characteristic equation is this, so we don't need to do that again. So this characteristic equation, that is s raised to 4 plus 3s cube plus 12s square minus 16s plus k into s plus 1 is equals to 0. So again I am rewriting this equation. S raised to 4 plus 3s cube plus 12s square plus k minus 16 into s plus k is equals to 0. Now second step of intersection to imaginary axis is to have a calculation of Routh array. So Routh array. Now in Routh array here order 4 is there. So s to the power 4, s to the power 3, s to the power 2, 1 and s to the power 0. S to the power 4 is having element 1, skip one element, and next is 12 and skip one element, and next is k. S to the power 3 that is having element 3, skip one element, next element is k minus 16 and further element is not present. So this is 0. Now for further calculation of Routh array we need to do cross multiplication. So 3 into 12 minus k minus 16 into 1 divided by 3. So that element that will be 52 minus k divided by 3, and over here this element is 0, so we can directly write k over here. Now for next element that is over here, we need to multiply this into this minus 3 into k divided by this element, and simplified one of that will be 52 minus k into k minus 16 minus 9k divided by 52 minus k, and over here next element for this will be 0, and here this element is 0, so last one that will be k. So this is how we can solve Routh array for this. Now in this, for stability, first column that has to be greater than 0. So for stability, this first column that has to be greater than 0. So that will explains marginal stability. So here this is what the coefficient which is there with s square, so we don't need to consider this coefficient. Now for this coefficient we'll be calculating value of k. So if I say for marginal stability 52 minus k into k minus 16 minus 9k divided by 52 minus k, that is equals to 0. So that will result, actually that should be greater than 0. That should be greater than 0. So again if I do simplification of this, so that will result into k square minus 59k plus 832, that should be less than 0. So again if I simplify this, then I will be having two values of k. The reason is this is second order of k. So one value of k should be less than 23.32. Just simplify that by having second order differential equation solution. So that will result into k should be less than 23.32, and second value of k that should be less than 35.68. So here we have two values of k's. Now we will be using auxiliary equation. So auxiliary equation, that is second order differential equation, which is this. So auxiliary equation is 52 minus k divided by 3 into s square plus k is equals to 0. Now in this, if I place k is equals to 23.32, so in that case I'll be having s is equals to plus or minus j 1.56, and by placing k is equals to 35.68, I'll be having s is equals to plus or minus j 2.56. So this is how I can have intersection to imaginary axis. So there are 4 points where intersection to imaginary axis is happening. Now let us use all those calculation for a plotting of root locus. So here I have a root locus diagram which we can see in this figure, and let us place all those things which is what we have calculated. So here we have poles at 0 and 1. So let us place all those things first of all. So pole is at 0, pole is there at 1, pole is there at minus 2 plus j 3.46, and another pole is there at minus 2 minus j 3.46. So sorry, this is minus actually. So minus 2 plus j 3.46. So minus 2 plus j 3.46 somewhere over here. So if I say this pole is over here, and second is at minus 2 plus j 3.46, and here minus j 3.46. So based on that, pole is over here somewhere, and 0 in this equation is at minus 1. So I will be placing 0 at minus 1. Now over here we have calculated asymptotes data. So asymptotes data are 3 asymptotes are there. Centroid at minus 0.67. So centroid of asymptote that is there at sigma c is equals to minus 0.67, and angles of asymptotes are 60, 180 and 300. So angles of asymptote with respect to this is 60, theta is equals to 60, theta is equals to 180, and third asymptote at theta is equals to 300. So that is how angles of asymptotes are there. And then we have calculated breakaway point. So which we can see breakaway point that we have calculated by 0.46 and minus 2.22. So 0.46. So that is somewhere over here. So this is as break, and that is happening at 0.46, and second is at minus 2.22. So second breakaway that is happening somewhere over here, and again I am writing as break that is happening at minus 2.22. So that is how breakaway is happening. Now let us initiate plotting of this root locus, which will explain how things are happening. And one more thing that we have calculated before I plot, intersection to imaginary axis. So intersection to imaginary axis, that is what we have calculated at plus or minus j 1.56 and plus or minus j 2.56. So plus or minus j 1.56, that is over here 1.56 j, and 1 is over here j 2.56, and over here minus 1.56 j, and over here minus 2.56 j. So this is our intersection to imaginary axis that is happening, which is what we have calculated. Now let us plot this root locus. So root locus that will always begin from pole where k is equals to 0. So k is equals to 0, that is there at pole, which is what I am indicating right now, and line that will emerge from pole and that will go towards breakaway. So line which is emerging from this two pole that will go towards this breakaway. So it will go towards this breakaway. This line that will go towards this breakaway, and after breakaway one line that will get enclosed to 0 where k is equals to infinite, and one line that will go to 180 degree asymptote where k is equals to infinite. Now from these two poles even line will emerge and that will go to breakaway, which is at 0.46, and after having breakaway this line is moving and touching to intersection to imaginary axis, and those two intersection are at j 1.56 and 2.56. So what happens is this line will go to 1.56, again come back and touches to 2.56, and again it will be moving towards asymptote where k is equals to infinite, and same thing is happening over here. This breakaway will go to 1.56, again it will intersect to imaginary axis, so it will touches to 2.56, and it will be going towards asymptote where k is equals to infinite. So that is how this root locus plot is there. Thank you so much for watching this video. If you have any query regarding root locus, you can ask definitely in comments so that we can have a discussion, and definitely I will help you to sort out those problems and queries which is there with root locus. Thank you so much for watching this video.